This is a really good. The recording is starting. Really exciting area of research, and I agree with Chris that there's a lot more for us to be doing. So I'm excited to hear about other works in progress in this area. So this paper is thinking about recent improvements in air quality in China and how they have shaped suicide rates over the last few years. This work is led by myself and Peng Zhang, who's at the Chinese University of Hong Kong. So many people in this room already know some of these statistics, but what we're looking at when we look at the global suicide burden is over 700,000 lives that are lost each year. And this is sort of a stark indicator of a much broader mental health phenomenon in which we have over 300 million people that are estimated to suffer globally from depression. You can see on this map, there's a lot of spatial heterogeneity in rates of suicide, and there's also been a lot of dynamic changes over time in recent years. Somewhat optimistically, we have seen a pretty consistent decline over the last two decades of suicide rates around the world. This is true if you look on average globally. It's also true if you look just in the OECD or even just in low and middle income countries. So this is encouraging, but understanding the reasons for these declining suicide rates is very difficult. There are a lot of interacting social, economic, cultural, and potentially environmental factors all at play here. And in general, the studies that have tried to look at explaining spatial and temporal patterns in suicide rates have focused on higher income countries, generally because that's where data are easier to access. But about 80% of global suicide deaths take place in low and middle income countries where this phenomenon has been less studied. Here, we're going to focus on China, where if you look at the graph on the right, you can see suicide rates, at least reported suicide rates, have fallen faster than in any other nation on Earth. And we're going to try to understand one potential driver of this decline. And in particular, we're looking at air pollution, and we're asking whether recent changes in air pollution have had any causal influence over this declining suicide rate. So we're going to work hard to try to design a study that allows us to pull air pollution out of that complex interacting set of factors and figure out if independently it's playing any specific role. And if so, then we want to ask how the suicide rate decline that we can see in the data may be attributable to improvements in air quality, in particular spurred by recent policy changes. The reason we are curious about whether these two phenomena may be related is if you just look at the data, they are both declining very precipitously over this period. So you see on the left, that black line is average suicide rates across the country, and the light blue is very fine particulate matter, PM 2.5. On the right, you're seeing trends in PM 2.5 since China's war on pollution, which began in 2013. You can see across most of the nation, pollution is declining. So, of course, many other things are taking place over this period. And if you look at the graph on the left, you see that there's many reasons to think these two things have no relation whatsoever, given that the seasonality in these two phenomena are incredibly different. So they're peaking at different times of the year, but they're both trending downward. So we're curious, are these two things related, or does it just happen to be there's a lot of trending variables happening at the same time? The reason we think these two could be related is because there is a body of neurobiological and epidemiological literature suggesting there can be links between air quality, mental health, and ultimately suicide. On the neurobiological side, there's evidence that particulate matter can shape available serotonin as well as other neurotransmitters, which then can lead to increased suicide risk through channels like emotional control. There's evidence from many different methods here, like brain imaging, brain samples, platelets. There's also some hypotheses that general inflammation could be a role linking particulate matter to elevated rates of suicide. On the epidemiological side, where we're looking at more population scale data sets, we see repeated evidence of positive correlations between particulate matter and suicide risk. A lot of the hypothesized mechanisms include deteriorating physical health that then leads to declining mental health, or even deteriorating economic productivity because people are less productive under high levels of air pollution that then may lead to economically motivated suicide. Most of this literature to date is in the US and in Southeast Asia. So the challenge with all of this research, of course, is that air pollution is inherently anthropogenic, which means that when we have elevated levels of air pollution, many other things are happening in our social and economic situations that could contribute directly to suicide. So traffic patterns, holidays, manufacturing activity, all of these things are going to change air pollution as well as potentially directly affect suicide risk. So our solution to this problem, which you will, I think, see later in another talk as well, is to use a random meteorological event which changes exposure to air pollution under the exact same socioeconomic conditions. So these are called thermal inversions, and I'll talk about them in a second, but basically they're going to trap emissions near Earth's surface so that when we have the same amount of pollution emissions coming out of our tailpipes, the actual human exposure is randomly elevated when these conditions take place. So what does this look like? Most of the time, you see this negative temperature gradient with elevation, so warmer air near Earth's surface and colder air above. This means that when we emit particulate matter and other forms of air pollution, they tend to distribute vertically. What happens in an inversion is that a warm layer of air comes and traps a cooler layer below it, then trapping the pollutants as well. So the same amount of pollutants may be coming up, but it's being trapped and elevates exposure for humans on the ground. This can happen for a variety of reasons: rapid cooling at night, air falling quickly through the column called the subsidence inversion, or a storm front can bring in warm air in this way. So in this short talk, I'm not going to get into all the methodological details, but basically we estimated 2SLS model in which we are isolating variation in particulate matter that is only driven by variations in these inversions, and we're going to use within county variation over time in inversion activity to do that. What we find in the first stage of that 2SLS model is that, like many other papers have shown, thermal inversions do dramatically elevate PM 2.5. One additional thermal inversion per week raises average weekly PM 2.5 by about 1%. We look at a variety of different ways of measuring inversions, and we continue to see robust evidence that these inversions increase air pollution, whether that's how strong they are or the number of days in a week that they take place. We then, in the second stage, show how that variation in pollution driven by inversions shapes suicide risk, and we see that a 1 standard deviation increase in PM 2.5 elevates the weekly suicide rate by 25%. So one thing I want to point out here is that the result we're getting with 2SLS is dramatically different than if we just looked at a correlational relationship, even if you saturate this model with many, many controls that are commonly used in the epidemiological literature. So this little OLS coefficient over here is a two-way fixed effects estimator that's trying to use fixed effects to get out all of these correlated variables that come along with air pollution. But we see that the effect is dramatically muted and statistically insignificant with that model. In contrast, we're able to pull out this causal effect with 2SLS. And then this effect is highly robust to a range of different controls. Like, happy to talk about method details if people are interested. We can change our fixed effects, how you control for other weather conditions on the ground, how you define that inversion instrument, etc. So we then look to see how different subgroups of the population are differentially affected. I think when Chris was talking about the many unanswered questions in this space, a lot of the unanswered questions come down to the mechanisms that link observable mental health outcomes and variation in the climate. And we're going to do our best here to try to think about mechanisms by looking at a lot of heterogeneity. So one way to do that is to split along different age and demographics. And one of the most important findings, I think, of this paper is to show that women over the age of 65 are by far the most sensitive to this phenomenon. So you see the coefficient here for females over 65. Men over 65 also have an elevated effect, although it's very noisy, whereas you see much smaller effects near zero for under 15 and very small for sort of younger populations. And I'll talk about some of the reasons we might be seeing this on the next slide, but I think this is really important to keep in mind, given that other literature on temperature and climate change driven changes in temperature and suicide has a very different story in terms of the demographic population. We also see these effects are higher in spring and in regions where there's a high average suicide rate. So there's a lot of other noisy sort of no effects on heterogeneity, but the sort of story that we're seeing overall from looking at all this heterogeneity is that the effects of air pollution are highest when baseline suicide rates are also high. So this is somewhat consistent with stories about contagion suicide effects. When baseline rates are high, these additional triggers can lead to much higher elevated risks. So I don't have the answer exactly to why older women are more susceptible. I'd be really curious if other people have insights into this, but it is consistent with a growing number of studies that show air pollution effects on the brain being more risky for women. So there's experimental evidence on the deposition rates of particulate matter for women and girls. So it's possible that more of it is getting deposed in the brain. We see that respiratory effects tend to be larger in women and girls and the elderly, but in particular, this last bullet point, we're also seeing that effects on dementia look larger for women than they do for men. So I think there's growing evidence here, but I personally don't know exactly the reason why we're seeing such a large effect. The last sort of empirical result that I want to highlight is that we find these effects are very rapid and short-lived. So what you're seeing here are the dynamic effects of these inversion activities on suicide rates directly. The reason we don't do this through 2SLS is through many weak instruments problems. But here you're seeing that when an inversion event elevates pollution, the effect on the suicide rate is in the same week of the inversion event, and that effect goes away immediately. And so some of the hypothesized mechanisms around physical health leading then to mental health declines don't, at least in this study, seem to be at play. Instead, this looks to be a direct, likely neurobiological effect, given that it's happening immediately and then going away right away. So we take those empirical estimates and then we ask, given dramatic declines in particulate matter due to very aggressive pollution control policies in recent years, how much of this suicide rate decline can we attribute to those policies that have reduced air pollution? And we're going to focus on this period where the China Action Plan for Air Pollution Prevention and Control was enacted and led to very marked declines in PM2.5. And basically what we're going to do is we're going to go back to 2013 and we're going to simulate using our reduced form estimates what would have happened had those air pollution control policies not come into play, and what would suicide rates across the country have looked like. And so this map is showing you the results of that simulation, where we're showing our estimated suicide deaths that were avoided due to the pollution declines achieved over this period of policy control. You can see widespread declines, particularly in highly populated areas where pollution declines were severe. This is just a rank order plot of those changes. So a lot of heterogeneity in the results of these policies across space, but with all of the mass being above zero. There are a few places where pollution got worse. Those are in Western and Northern China, where prior literature shows us it's largely due to changes in dust patterns and not anthropogenic emissions. Overall, about 46,000 suicides we estimate were avoided due to just 5 years of pollution reduction control, explaining about 10% of that overall trend. So lots of other things are going on and driving the suicide rate down, but we think around 10% of it can be attributed to these air pollution control policies. Just to put this in context, especially given that we're talking more broadly about climate change and mental health here, in my prior work looking at temperature-related suicide and in the Indian context, to put these numbers in perspective, a similar number of suicides I estimate there was avoided due to 30 years of climate change in India, whereas we're seeing these 5 years of pollution control in China leading to about the same, similar magnitude of avoided deaths. So I think climate change is really important, but thinking about air pollution alongside it, I think, is really critical, given how policy levers on pollution can really rapidly change this source of risk. So I'll just wrap up here. We find that air pollution has a substantial effect on suicide risk in China. About 10% of the declining trend we think can be attributed to pollution declines. We see these effects happening very immediately, and they're much, much larger for older women. I think there's a lot of unanswered questions about why. And that in general, pollution prevention policies that are being debated and repealed or enacted around the world have really important and measurable mental health implications that we should continue to study. Thanks so much for your time, and I'll hand off to Chris.
Thank you, Tama. That was brilliant and well timed. Lots of topics for us to come back to there, so I won't dwell on it now, but there's a few things that it will be interesting for us to pick up. Let's go straight to James with your presentation.
Thanks, Chris. Let me try and get... This might not be seamless. Wait a sec. Display settings. Are we okay? Can you see me?
We've got your slides, yeah.
Perfect. Right. So, bit of a change of direction from what Tama was just discussing, but the work that we're doing is sort of linked. So what I want to do today is talk about two different aspects of this work. So firstly is a broad literature review of mental health impacts of climate change, but also firstly want to link that to some of the work that we've been doing on multi-exposure decision tools. So what we've been doing in this work, in this net zero work is sort of linked in a way to some of the work that Tamara was discussing in terms of quantifying the burden, but doing it within a decision tool for regional policymakers to use and to help them kind of do their job. So yeah, 2100 is sort of the date that we're looking at in terms of projecting effects forward for regional policy making, and we know there's a lot of bad things are going to happen by then. So I asked AI for a vision of what 2100 look like, and it doesn't look good. So we've got drought in there, rising sea levels, floods, and heat waves. So essentially what we're trying to do in our work is look at what will these things do to health, what are the actual impacts going to be upon health of all these bad things that are going to happen, but what also can we do in terms of policy in order to mitigate and increasingly adapt to what this future is going to look like. So we're working mostly in a region of the West, a region called the West Midlands in the UK. And UK at the moment, I would say, is almost entirely focused upon, certainly regional government is focused upon adapting to climate rather than mitigation. And so a lot of the policies that we're looking is thinking about how we adapt to what's going to happen. There's a lot of interest from policymakers in thinking about adaptation and evaluating the health co-benefits. Okay, so that's like, if we do adapt to climate change, what could also be achieved for health? Okay, and the approach that we take is very similar to that last part of the process that Tamara described, where you've got a change in an exposure, which she showed air pollution, and you've got a likely impact upon health. Okay, so we're trying to do it. I'm a health economist by background, not an epidemiologist. So I'm trying to take a health economic approach to what we're doing. And so that's required me to sort of rethink about how we do our analysis and what our decision-making audience actually wants. So climate policy in UK takes place across not only the climate department, but also transport, energy, and housing. And actually each of those sectors, national and regional government, evaluate policy in slightly different ways. So we had to produce a decision tool that's actually quite versatile, that can do things for all different departments. So there's that to think about when providing decision support. The major challenge, I think, for us was we came into a space where morbidity burden was usually assessed with DALYs and national DALY multipliers. So if you've got asthma, you lose X amount of DALY and you have it for 12 years or whatever the multiplier is. And that was the calculation with one value that was being used across the country. And often these values weren't even derived, these multiplier values weren't even derived from the UK. So we thought we need to do something differently here. And so what we decided to do was to build a model that could reflect the population structure and its evolution over time. So hopefully, as health economists, we're all thinking, well, maybe this sounds like a job for a decision model, and it is. So what we decided to do was build at first a Markov model, which evolved into a simulation model, and to put population into states of health for diseases that we think are attributable to air pollution. So apologies here, I don't have any mental health outcomes. This was the provisional framework that we developed a few years ago now. And so what happened with this model is we co-developed it with our stakeholders in terms of inputs and outputs to make sure that it really had that impact in decision making. So we did some cool stuff, like trying to calculate what would happen if the West Midlands complied with WHO air quality guidelines. So again, sort of how many lives would it save, what would be the quality gains, and what would be the economic benefit. We also produced these maps for the West Midlands, which is right in the centre of England, if you don't know where it is. And again, this was thinking about how air pollution was playing a role in the current disease burden in our region. Okay, so this is where we move on to the mental health stuff. And so we started to think, well, why are we only doing air pollution here? Because actually, if we think about climate, we know that the climate has lots of different impacts. There are many different exposures which will be impacted by climate change. And so we then decided it'd be a great idea to develop a tool that had lots of different exposures in it. By exposures, we mean sort of factors of our environment or the way that we live our lives that then have downstream impacts upon health. And so these exposure pathways are not just things that we think would change as the climate evolves, but they're also things that policy to adapt or mitigate would actually influence. So noise, for example, is a good example of something that maybe the climate wouldn't change, but policies like electric vehicles to mitigate climate change would indirectly influence. Okay, and so now we have mental health as an outcome in our model. And this meant that then we had to go away and do a literature review around the potential pathways through which all of these different 7 exposures would subsequently influence mental health. And then obviously those mental health impacts would then have health economic impacts that we would want to quantify in our model. So we've done some sort of provisional analysis here in these small maps in the bottom right. The green one is the effect of green space upon mortality. So the green bits are good, the yellow areas are not so good. And then on the right-hand side is some scenario modelling, whereby we modelled an increase in cycling to work and what would happen to the mortality rate. And again, nearly 2% reduction in overall mortality through just 20% of people cycling to work. So this is the kind of thing that the tool is set up to do. But in order to do it, we need the studies of the type that Tamer was describing in order to parameterize those effects. So we got various different mechanisms through which we did a lot of research around how climate change would impact mental health. And there's lots of research out there that sort of is suggestive, is early research at this stage that obviously needs more work and more development. But there are these sort of principal pathways that we can see these operating through. So firstly, more extreme weather events, so flooding and drought causing anxiety and psychological traumas, if you like. High temperatures, which are shown to have behavioural impacts, behavioural manifestations, and including increased mortality. And then this kind of new research area, which is around how climate change impacts, they must call it the sort of anxieties that people would have around helplessness or fear of the future. And then also these community level effects around resource shortages. So we have these sort of 4 pathways that we can think of. We thought, well, what do we need to do about this for the UK context for the West Midlands? So first we went to flooding and looked at mental health impacts of flooding. Some suggestive evidence that flooding is linked to anxiety and depression. So we will include that in the model. Over 10 million Europeans reporting mental health disorders from floods in the past 2 decades. And the thing about flooding, particularly in the UK, is that it widens inequalities as socioeconomically disadvantaged are more likely to live on floodplains. We also have this issue of increased temperatures. So increased temperatures linked to crime and aggressive behaviour, partner violence, and also suicide risk. Some of the work that we're doing here in Birmingham is looking at the relationship between extreme temperature and mental health related admissions. So we're doing the statistics on that as well as the modelling. And again, this is something that looks like it's going to widen existing inequalities because people with pre-existing mental health conditions are more vulnerable to high temperature. And we also thought we've got quite a lot of wooded land to the north of our region. We could be looking at increased frequency and intensity of heat waves leading to forest fires. So forest fires actually known to be associated with depression and other anxiety manifestations, even years after. So this can really unsettle people for a long time. So we definitely need to model this in the work that we do. We're also looking at green space in our model. So green space is known to have a restorative effect on mental health. I could have just said protected. And so if green space disappears, we would expect rates of depression and anxiety to increase. And again, likely to widen inequalities as socioeconomically disadvantaged lose access to green space. Provisionally, I'm not going to say that this definitely goes in the model, but we're certainly looking around what we can do to include some kind of some of the mental health impacts of climate anxiety in our model as well. So how do I sort of summarize all of this? Well, we think it's really important to build these decision tools that can help regional and national policymakers to prioritize policy that has health co-benefits. In order to do that, we need to think about right across the exposure pathways. So not just thinking about air pollution or temperature, but other things like floods and heavy rainfall. And we need to think about how each of these exposure pathways in turn influences mental health, and then work together with our sort of regional policymakers and national policymakers to ensure that the tools that we produce speak to their existing evaluation approaches as well as their policy priorities. Okay, thank you.
Great, thank you, James. Laid down the gauntlet there. There's clearly an overwhelming number of pathways that we want to be thinking about and considering how we ought to model, and then how we ought to think about evaluating policies targeted at those pathways. Lots to be done. Let's move straight on. Beta, over to you.
Yeah, thanks. Sorry, so Control L. Okay, are you now seeing it in full screen? Perfect. Okay, so yeah, with my talk, I will move us back to air pollution and specifically the causal effects of prenatal exposure to air pollution on socio-emotional skills during childhood. So the motivation for this project was existing research, which shows that being exposed to higher levels of air pollution while in utero causes a reduction in educational achievement and even earnings during adulthood. And the broader question I'm interested in here is what are the mechanisms which drive these long-run effects of prenatal air pollution exposure? And there already is, of course, quite some research on this with evidence that prenatal air pollution exposure leads to lower cognitive ability later in life and also to worse physical health during childhood. But for a third very crucial component of human capital, evidence is missing so far, namely for socio-emotional ability and mental health. So this is kind of the gap I want to fill with this paper. I want to understand whether changes in socio-emotional skills and mental health, I will say more about the relation here later, also contribute potentially to these long-run effects of air pollution. And why should we care about this specifically? Because, of course, understanding the relative importance of these different potential channels is crucial if you want to think about how to design optimal policies to address these long-run impacts of early air pollution exposure and all the implications for equality of opportunity. So to study this, I'm using data from a long-running representative household survey in Germany, the socioeconomic panel. As part of this, mothers are asked to rate their children's socio-emotional skills when the children are aged 5 to 6, and again when they are 9 to 10. And for this, two very widely used taxonomies are employed. For one thing, the Big Five personality traits. If you haven't heard about them, this comprises openness to experience, conscientiousness, extraversion, agreeableness, and neuroticism. So different dimensions of socio-emotional ability. And secondly, mothers also fill in the Strengths and Difficulties Questionnaire, or SDQ, with a large number of items which can be aggregated into 3 scores. The first measures externalizing behavior that relates to conduct problems and inattention and hyperactivity issues. The second score is for internalizing behavior, which is related to emotional and peer relationship problems. And finally, a score for pro-social behavior. And the SDQ is actually one of the most widely used measures for child mental health. So there's a direct link. And with the Big Five, kind of the mainstream view in psychology, as I understand, is that there's a range of normal variation in these personality traits, but very extreme realizations are indicative of mental health issues. So especially when you're studying children, I'm always going to talk about socio-emotional skills here, but these two concepts are very tightly linked. Okay, and importantly, the survey also includes information on kids' year, months, and county of birth, which then allows to link these outcomes with information on environmental conditions during their prenatal period. And most importantly, of course, air pollution. So I think just like Tama and her work, I focus on PM2.5, fine particulate matter, as the primary measure of pollution. And this is from satellite observations. And on top of that, I collect data on weather conditions to add as controls. To give you an idea, the sample for the Big Five outcomes consists of roughly 11,000 observations. For the SDQ-based outcomes, it's a bit smaller with 7,000 observations. And these refer to children born in Germany between the year 2000 and 2014. And in the sample, the average PM2.5 concentration during the prenatal period is at 14.5 microgram per cubic meter. So I would say a moderate level. For perspective, this is kind of right in between the very strict WHO guideline of 5 micrograms per cubic meter and the much more lenient European Union limit value of 25. Okay, and with the data, I could then just estimate this baseline regression here, where the outcome of interest is a standardized measure of socio-emotional ability for an individual I born in a county C in year Y and month M, and these are assessed at age A. Because to maximize the number of observations here, I'm pooling across observations from the 2 age ranges, 5 to 6 and 9 to 10. And on top of PM2.5, the regression includes flexible weather controls and some background characteristics like parental education, for instance, and the whole set of fixed effects for county, year, and months of birth, and the age of skill assessment. But here, I'm very lucky. I don't have to go into the details because Tama already explained this in her presentation, with the usual issue that pollution is endogenous, it's measured with error, and it can be correlated with relevant omitted variables like local economic conditions. And I'm using kind of exactly the same approach to address this, an IV strategy using thermal inversions. And here, because I'm considering a longer period, the instrument is the frequency of temperature inversions during a child's prenatal period. So then let me move on to the main results. So the upper part of the table shows the estimated effects of a 1 unit increase in PM2.5 during the in utero period on the big five. And as you can see, the main finding is an increase in neuroticism by 13.5% of standard deviation. What this means is that affected children have lower emotional stability. They tend to be more fearful and less self-confident. So that's what this outcome means. For the other 4 dimensions, I don't find any significant effects. Most point estimates are also very small. The only exception here is for openness, which is a quite sizable negative coefficient. That's not very surprising because openness, as it is measured for children, likely captures to some extent cognitive ability. And we already know from previous research that prenatal air pollution exposure can reduce cognitive skills. So the direction here makes sense, but as you can see, it's quite a bit smaller than the effect on neuroticism and not significant. And the same pattern is basically observed when we look at the SDQ-based outcomes. So here, main result is an increase in internalizing behavior by 18.5% of standard deviation. And this is kind of strongly related to neuroticism. So these outcomes here are not independent, but they are correlated. Both refer to emotional instability. So this is very much consistent. And the same for these other dimensions here, pro-social behavior and externalizing behavior, in line with what I saw for the other big five. There are no significant effects on these other dimensions of socio-emotional ability. So the headline result is that prenatal exposure to air pollution reduces emotional stability during childhood, so 1 dimension of socio-emotional skills. And now, of course, an important question is, what about the effect magnitude? So is this meaningful? Is this large? Is it small? I'm doing a couple of things to get a better understanding of this. One is a comparison of the effects of PM on these emotional stability outcomes and on cognitive ability, because the survey also includes further questions that allow me to build proxies of cognitive skills. And what I see there in this comparison is that the effects on emotional stability here are clearly larger than on cognitive skills, which are mostly even insignificant. So at least in this setting with moderate pollution, emotional stability seems to be more susceptible to air pollution. Another thing, coming back to my motivation in the beginning, is the back of the envelope calculation, which suggests that this emotional stability channel can account for at least 37% of the total long-run earnings reduction due to prenatal pollution that has been reported in earlier work. So both steps together, basically, I would say, imply that this emotional stability outcome is a quantitatively relevant channel for long-run effects of air pollution. Okay, and finally, I also compare the effects that I find here for pollution to effects on neuroticism that have been found for other interventions and treatments. And I think one comparison that is quite interesting is I find that the effect of a standard deviation increase in prenatal PM2.5 on neuroticism is basically the same magnitude as an effect that has been reported for a household receiving an unconditional cash transfer of $3,500. So also implying that this is a quite meaningful effect magnitude. Okay, then there's one more result I want to show you before wrapping up. Here, given the main result, I then try to explore where is this coming from, who is driving this overall increase in emotional instability. And one thing I did were unconditional quantile regressions to see where in the distribution we see most action. And here these results are for internalizing behavior. And these are not 2-stage least-square estimates, but reduced form estimates. So it's for 1 standard deviation increase in inversion frequency. And the pattern is quite clear. So you see the largest effects at the top deciles of the distribution. So it's kind of the takeaway is it's kids who score already high on internalizing behavior in this case, who then see the biggest effect of air pollution, which I would say is particularly concerning because Of course, the higher range of the score is where we see the biggest risk of then developing mental health issues. Okay, and with this, let me conclude and maybe come back to the title of the webinar, because up to now, of course, I've never used the term climate in my talk. So my result here is that prenatal exposure to air pollution has adverse long-run effects on socio-emotional development, particularly kids' emotional stability. In what way is this relevant for climate? I think it was already mentioned before, of course, particulate matter and greenhouse gases are co-pollutants. They largely stem from the same sources. So the relationship here is that any climate change mitigation policies that reduce fossil fuel consumption can yield important co-benefits in terms of reducing air pollution and all the health effects that have been shown in the literature, including these effects on socio-emotional ability or mental health. So thank you very much.
Brilliant. Thank you, Beta. Okay, we'll get all of our speakers on screen now, and yeah, let's discuss some of the topics that we've covered so far. So I thought all of your presentations were brilliant and contribute really important research to this area that, as we've mentioned, is so far underdeveloped. And I wonder if part of the reason why it's underdeveloped is the complexity. So the first topic I wanted to raise for discussion was the many exposure pathways that have been mentioned during the course of this session, and challenges in identifying the causal mechanisms underlying those exposure pathways. It's super complex. I wonder if there are just too many for people to deal with, and whether there's merit in focusing our attention on some particular pathways, particular causal mechanisms. So I'll come back to you, if I may, Tamer, as we've not heard from you in a while. What's your view on this? Do you think that we, as economists, as health economics researchers, ought to be focusing in on particular mechanisms that we think are going to be the most fruitful?
I'm going to give you a non-answer, which is that I think we need to be clear about for which policy we are aiming to inform with our work. So I think there are settings in which studying the reduced form without being able to map out the causal pathways is actually sufficient, as well as long as you're getting that reduced form identified very well. So, what are we good at? We're good at causal identification. And if we can provide reduced form estimates that say, I don't know the mechanisms, but I can tell you that an elevated degree of temperature or an elevated quantity of PM 2.5 is causing this outcome, for some sets of policies, that is sufficient, particularly mitigation policies, right? So if we're interested in, how far should you go on pollution control, back to that conversation about WHO versus UK levels, or how far should we go on climate change mitigation, those reduced form effects without being able to talk about the mechanisms are actually sufficient. If you're talking about adaptation policies or informing mental health providers about how these are operating and what they might be able to do to, given an air pollution, a very highly polluted day, what they could be doing in their practice, then I think we need to be working on the mechanism. So I think that's sort of a non-answer, and that I think we should be careful that we don't always need to map out all of the mechanisms in order to inform policy. And then, I don't know, I guess maybe my answer to, if you really want to get at mechanisms, should we only focus on a few? I think my answer would be we should get more people studying this so that we can study all of them. I don't think we have enough priors to know which ones are most important. So I'll just try to be brief, but before I wrote this paper, I had been working on climate change, and the story in India is like, this is an economically motivated suicide pathway in which temperatures were damaging crops, and we were seeing long lag lengths, and those were having knock-on effects years later because economic outcomes were affected, and that was precipitating suicide. It's a very different story than this single week PM effect in China. And I don't think we knew that before we started writing these papers. So I would be worried about saying we know enough to focus in on a couple mechanisms at this point in time, because we might be leaving some really big stories on the table.
That's a really good point. Just over to you, James. So, I mean, do you find that encouraging, given how many potential pathways you're thinking of considering in your modeling. Your work is obviously very policy focused and quite locally policy focused. How concerned are the policymakers that you're working with? How concerned are they about causal mechanisms?
It's difficult to answer that diplomatically. I think within organizations there are analysts that are highly focused upon detail. I think like top level decision makers quite often want a number. Certainly regional level, they want numbers and they want a narrative to accompany those numbers that leads in a certain way. So I don't think it's a policymaker discussion. I think it's an academic discussion, and it relates to the sort of ethical. It relates to an ethical issue for us because we're presenting them with numbers, and so it's our sort of responsibility, if you like, to make sure that what we're presenting them leads to the best policy making that it possibly can. And I think, certainly if they get the numbers, we give them the numbers. I think there's a level of trust, in my experience, in the fact that these numbers have come from our university. But I still think we have to get it right in those terms, and it is very difficult, particularly because 3 of those pathways, weather, air pollution, and noise, it's almost impossible to detangle the effects of those 3 things. Particularly the data. I mean, we have real problems with the health data in the UK. Health data, we don't have that sort of spatial. We don't have the sort of spatial differential that other countries have. So it's very difficult for us to do the sort of statistics upon this. And so often we end up having to go to work from other countries even to inform our local models. So health data is the principal problem. But I wouldn't say policymakers specifically are overtly worried about these issues, but I think we should obviously take them seriously.
Yeah, finding those experimental conditions, I agree, is quite challenging in the UK at least, and no doubt in other places. You mentioned the importance of numbers there, James, in persuading policymakers of the need for change, I suppose, and particularly thinking of adaptation and mitigation strategies. Time is of the essence, as we know, so making sure that our research informs policymaking is important. And with those numbers in mind, I was reminded, Beta, of the cash transfer equivalent that you provided us with. Thinking about your work and the potential for your work to inform policymaking, I guess there's another level of abstraction when we think about prenatal exposure and downstream outcomes. Is it important to be able to characterize things in terms other than socio-emotional impacts?
So to also know effects on other outcomes, or
other outcomes, and I suppose outcomes characterized in monetary terms.
Yeah, I think for policymakers often having an idea of effect magnitudes in monetary terms helps to balance costs and benefits, and to just get a better idea of what these effects mean. But I think a challenge with all this research on socio-emotional skills and mental health is also that kind of I think we also need support from other disciplines, because my feeling as practitioners and policymakers so far don't even have this on their radar, that there is this link between things like air pollution, also temperatures, other climate change impacts, and mental health. So for instance, air pollution is very much linked to asthma and other issues. So I think it's important that we identify the causal effects and these mechanisms, but I think we also rely on other disciplines to provide more information, for instance, on these neurobiological pathways, because often I think policymakers and practitioners also have a bit more trust if it comes from medical people, let's say, and they can provide some background for this. So I think that's always challenging. If you, I mean, Tana also mentioned that we know air pollution affects so many outcomes. It affects economic outcomes, but also it has these direct biological effects, and disentangling this is difficult. And I think it also, we cannot do it alone as economists, but we rely also on other disciplines.
That's a really good point. And we're running out of time, so maybe a good segue into a final question for each of you. Because I think we've even just in the few presentations that we've seen today, we've heard about the need for a variety of different methodologies, microeconometric methods, simulation, decision modeling. These are within our toolkit, and it's quite clear that we need to be using all of them. And as you just mentioned, Beate, we need to be able to speak to other people. So my question to each of you, and I'll go to each of you in the order in which you spoke, is what's the most important thing to do next for us as a research community? Is the challenge methodological? Is the challenge identifying data? Is the challenge speaking to other people? From your perspective, how do we create a shift in the health economics world to enable us to do a better job of researching mental health outcomes and environmental sustainability interventions and climate change? What's the most important thing to you, Tama, first?
Great question. I think I'll answer by sort of revealed preference, the things that I'm prioritizing, which I guess are what I think are most important next. So I do think, obviously there's always more we can do on methods, but I think I would underscore your data point, particularly in low and middle income countries. I think we have focused, the research has focused where the data are, which makes sense. And I think we're in an era where we can get a lot more creative about data. And, Beate has done really exciting work using GitHub data. Like what are other data forms we can use to try to characterize mental health in places where we're not going to have repeated statistical surveys on mental health outcomes, but where climate change impacts are likely the largest. And so I think I've been working to try to pull together, suicide is just one indicator. It tends to be the one I focus on because the data are easier to access than creating more complicated mental health indicators like socio-emotional indicators as well. And so I'm working to build a publicly available database where more people can access suicide data that is combined with air pollution and climate information and easy to use in analysis going forward. And they don't have to do all the geospatial modeling. And then I think the other one, I'm just going to steal Beate's point on interdisciplinary collaboration. I'm a part of a group called the Neuroclimate Working Group. It's a really interdisciplinary, mostly neuroscientists that then have broadened out into bringing in people like us as economists. And I have learned so much from their webinars and from presenting there. And there's a lot of collaborations coming out of it. So I think the more we can speak across these disciplinary boundaries, the more we're going to break through innovative research-wise.
Thank you. All right, James.
Yeah, I would echo that entirely. I didn't really mention it in my presentation, but most of the work that we do is alongside groups in geography that are modeling air pollution, modeling temperature, modeling noise, modeling green space, and did the physical activity myself, but all the other things they've modeled. So you have to get that sort of modeling done first in order to get the sort of spatial variation in the exposures, that then you can then attempt to try and do that work with health outcomes. For us, again, exactly the same, it's data. So I keep trying to get studies funded to do data, but keep getting funding for modeling. The problem is that the modeling needs better data. I don't know if it's just weak bids that I put in, but it is really important to get this data issue sorted. And there's so much local and regional and national variation. Nationally specific coefficients are important, I think, we can't use what's happened in China really in the West Midlands. So we need to have, we need studies.
All right, thanks, James. And Berta.
Yeah, I can also only agree to the points that were made, especially data. And I think also especially with mental health, so much is happening kind of at a subclinical level, right? There's so much stigma often still attached to mental health. So only a fraction of all people who are affected consult a doctor or get a mental health diagnosis. So I think there's a lot of need for data to study this at a more subclinical level. If any German policymakers ever are watching this webinar, I know that they actually conduct screenings of all children who start school in a lot of dimensions, including socio-emotional development. So the data even exists, but often you just don't get access as a researcher. It's not shared or made available. So I also agree that this is one of the most important points. And I think to get our results to the policymakers, I think indeed also the collaboration with other disciplines and kind of bringing the credibility from all the different experts would be really important. So it's cool to hear that you are part of a group already and actively working on that. So.
Brilliant. Thank you, everyone. Thank you for your presentations. They were excellent. Thanks to everyone in the room for joining us today. If you're watching the recording, please do note our eagerness to connect with other people, share the recording widely, get more economists and non-economists on board with this topic. The IHEA Congress, which is happening next month, has lots of interesting work on mental health, lots of interesting work on climate change and environmental sustainability, not so much on the interaction of the two. So hopefully the next Congress in 2 years will address that, and hopefully some of the people watching this webinar will be involved. Not much more for me to say. Thank you again to everyone for contributing. If you're not a member of the Mental Health Economics Special Interest Group, please join us, and we'll hope to see you all soon. Thank you.
Thank you, Chris.
Thank you very much, Chris, for organizing, and thank everyone for your contribution. It's been fantastic. It's too little time, but maybe yes, more to come. Thank you so much.
Thanks, everyone.
Thanks, Chris.
Bye.